students, good morning to all. How are you? I hope all are fine. Welcome back to our science class. Okay, today we are going to discuss about a new chapter, acids, bases and salts. Are you ready? Okay. These are the important points we want to discuss in this video. First one, acids and bases. Second one, indicators. Indicators it includes Litmus, Turmeric and Sine Arrows indicators. Okay, then neutralization. These are the main points we want to discuss in this video. We use in our daily life a large number of substances such as lemon, turmeric, common salt, sugar and vinegar, etc. Do they have the same taste? No. Let us recall tastes of some edible substances listed in this table. Okay. First one, lemon juice. It has sour taste. Orange juice have sour taste. Vinegar have sour taste, and curd, tamarind and also grapes and unripe mango have sour taste. But in the case of sugar, what is the taste of sugar? Yes, sweet. Common salt, salty. Then baking soda, bitter taste. You find that some of these substances taste sour, some taste bitter, some taste sweet and some taste salty. So we can say that in this curd, lemon juice, orange juice and vinegar taste sour. So these substances taste sour because they contain what? Acids. They contain acids. Some substances taste sour because they contain acids. For example, lemon juice, curd, etc. The chemical nature of such substances is acidic. The chemical nature of such substances is what? Acidic. The word acid comes from the Latin word acere, which means sour. These are about acids. So we can say that some substances taste sour because they contain acids. The chemical nature of such substances is acidic. And the word acid comes from the Latin word acere, which means what? Sour. Okay. What about baking soda? Does it also taste sour? No. If not, what is its taste? Yes, bitter taste, since it does not taste sour. It means that has no acids in it. It has no acids in it. It is bitter in taste. If you rub its solution between fingers, it feels what? Soapy. When you rub the solution of baking soda between your fingers, you feel soapy. So we can say that substances which are bitter in taste and feel soapy on touching are known as what? Bases. So we can say that the nature of such substances are said to be basic. Okay. Substances which are bitter in taste and feel soapy on touching are known as what? Bases, and the nature of such substances are said to be basic. These are about base, acid and base. Now we can move to some substances and acids present them. Okay, first one, what is this picture? Vinegar. We are very familiar with vinegar. In vinegar, which acid is present? Acetic acid. Okay, acetic acid is present in vinegar. These are some natural acids. Acetic acid is present in vinegar. Second one, what is this? Yes, this is lemon. In lemon juice, citric acid is present. Lemon juice, citric acid is present. What is this? Spinach. In spinach, one acid is present Which acid? Oxalic acid. In curd, this picture of curd, in curd lactic acid is present. In amla, ascorbic acid is present. In grapes and tamarind, tartaric acid is present. Both of them contain tartaric acid. So we can conclude that some acids and their substances where it is found. First one, acetic acid. Acetic acid is found in vinegar. Formic acid. Do you heard about formic acid? Yes, it is found in ant's sting. Okay. Then citric acid is present in citrus fruits such as orange, lemons, etc. Then lactic acid is present in curd. Oxalic acid is present in spinach. Ascorbic acid or vitamin C. Ascorbic acid is also known as vitamin C. It is present in amla, citrus fruits, etc. Then tartaric acid is present in tamarind, grapes, unripe mangoes. Okay, these are all about the names of acid and the found in substance. So this is very important. Next one, some name of bases. This is bases and found in which substances? First one, calcium hydroxide. Calcium hydroxide is one of the base which is present in lime water. Second one, ammonium hydroxide. Ammonium hydroxide is another base which is present in window cleaner. Third one, sodium hydroxide or potassium hydroxide is present in soap. Magnesium hydroxide is present in milk of magnesia. We are already discussed about acids and bases and also the examples of acids and bases. So, if we cannot taste every substance, how do we find its nature? We know that in lemon juice, orange juice, vinegar, etc. we can taste. But some substances we can't taste. How do we find its nature? Yes, special type of substances are used to test whether a substance is acidic or basic. Okay, these substances are known as what? Indicators. Okay, special types of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. The indicators change their color when added to a solution containing an acidic or a basic substance. For example, turmeric, litmus, Sine Arrows petals, etc. are some of the naturally occurring indicators. Okay, then when we want to check a substance is acidic or basic, we use indicators. Some of the natural indicators are turmeric indicator, litmus indicator, Sine Arrows petals indicator. Okay, these indicators change their color when added to a solution containing acidic or a basic substance. Okay, so we can study more about indicators. Natural indicators around us. Some of the natural indicators around us. First one, litmus, a natural dye. One of the natural indicator is litmus. Okay, what is litmus? The most commonly used natural indicator is litmus. It is extracted from lichens. It has a mauve or purple color in distilled water. When added to an acidic solution, it turns red, and when added to a basic solution, it turns blue. It is available in the form of a solution or in the form of strips of paper known as litmus paper. Generally, it is available as red and blue litmus paper. Okay, these are about litmus. Litmus is one of the most commonly used natural indicator and is extracted from where? Lichens. Okay, it has a purple color in distilled water. When added to an acidic solution, it turns which color? Red color. and when added to a basic solution it turns blue color. It is available in the form of both solutions and also strips of paper called litmus paper. Okay, generally it is available as red and blue litmus paper. This is a picture of lichen. We say that lichens, litmus paper or litmus is extracted from lichens. Okay, then this is the litmus paper strips, red and blue litmus papers. So now we can move to watch one video. That's how we can make a litmus paper. Are you ready? Okay. Okay students, then we can move to one activity, that by using litmus paper. Okay, so we can watch the change of acid solution and basic solution. So from our activity we can say that in vinegar, what is vinegar? Vinegar is, we know that is acidic. So its effects on red litmus paper is, there is no effect when it is an acid. So it turns red blue litmus paper into red litmus paper. Okay. Then in baking soda, we know that baking soda is a basic. So in red litmus paper it turns blue color, and the blue litmus paper there is no effect. And soap solution is also basic, so it turns blue. Red litmus paper turns blue, and blue litmus paper there is no effect because it is basic. So we can say that in these acids turns red litmus paper into blue litmus paper, and basic solutions turns blue litmus paper into red color. can move to the next natural indicator, turmeric, natural indicator. We are very familiar with turmeric. Okay. First of all, we can watch one video that show how to make a turmeric indicator. Okay students, now we can move to one activity. Some substances are given and to check whether it is acidic or basic by using turmeric indicator. Okay, are you ready? Now we can move to the next natural indicator. Third one is Sine Arrows as indicator. First of all, we are going to watch one video how we make Sine Arrows indicator. Are you ready?
You need 3 or 4 China roses.
Take a container and pour some water. Now heat this water. Now it is boiled completely. Take China rose and throw it in the hot water. Mix the China rose in water with spoon and leave it for 20 minutes. After 20 minutes, it become colored. Now separate the petals of China rose. Now our solution is ready.
Okay students, are you watched this video? Okay, now we can move to one activity that some solutions are given in, and you can check whether it is acidic or basic by using Sine Arrows indicator.
This is China rose indicator and these are the solutions. This is basic solutions, detergent, soapy water and baking soda. And these are acidic solutions, grapes, lemon and vinegar. We have to add few drops of China rose indicator in all solutions. China rose indicator turns acidic solution to dark pink and basic solutions to green. Therefore, these are turns into dark pink, so these are acidic solutions, and these are turns into dark green, so these are basic solutions.
Okay, so we can conclude that there is some stress solutions are given, so we check the nature of these substances by using Sine Arrows indicator. So when we check shampoo test solution, shampoo solution, we can say that its initial color is white, but when it is added to the Sine Arrows indicator, it turns green color. Why? Because this shampoo is acidic or basic? It is basic solution. Okay, this Sine Arrows changes its color when basic solutions are added to it. Okay, then lemon juice. What is the color of lemon juice? In initial color is colorless, but when it is added to the Sine Arrows, it turns dark pink color. In the case of vinegar, also it is colorless, and when we add to Sine Arrows indicator, it turns dark pink color because this lemon juice, vinegar, etc. are acidic. Okay, then sugar solution. We know that sugar solution is a neutral solution, so it does not change its color. Initial color and also final color are same, colorless solution. Okay, so we can conclude that Sine Arrows indicator turns acidic solutions to dark pink or magenta and basic solutions into green color. Okay, now there are some acids are given, acids and bases are given. Then the effect of litmus paper are given, and also the effect on turmeric paper and effect on the Sine Arrows solutions. Okay, first one, dilute hydrochloric acid. This dilute hydrochloric acid is not a natural acid. It is available in lab. So this dilute hydrochloric acid turns blue litmus paper into red color because it is acidic solution. So it turns blue litmus paper into red litmus paper. Okay, then effect on turmeric paper. What is this effect on turmeric paper? Is it an effect? No, there is no effect on turmeric paper because it is it is acidic. Effect on Sine Arrows, dark pink color. Sine Arrows solution, dark pink color because it is acidic solution. Second one, dilute sulfuric acid. Sulfuric acid is also an acidic, so it turns blue litmus paper into red color, and there is no effect on turmeric paper. Sine Arrows solution turns dark pink color. Third one, dilute nitric acid. It also acidic, so it turns blue litmus paper into red litmus paper. There is no effect on turmeric paper and dark pink color on the Sine Arrows solution. Then next one, sodium hydroxide. Sodium hydroxide, is it acidic or basic? It is basic solution. So it turns red litmus paper into blue color. And there is color change in turmeric paper. This turmeric paper turns red color. And also in the Sine Arrows solution turns green color. Okay, because it is basic solution. Then ammonium hydroxide. Also the same effect. Red litmus paper to blue color. It turns red. Turmeric paper turns red and the Sine Arrows solution turns green color. Then calcium hydroxide. Calcium hydroxide is also a basic solution. It turns red litmus to blue and turns turmeric paper into red color and Sine Arrows solutions into green color. Okay. Now we can move to another topic, our last topic, neutralization. What do you mean by neutralization? We have learned that acids turns blue litmus red and bases turns red litmus blue. Let us see what happens when an acid is mixed with a base. Okay, we are going to use an indicator. You have not used it so far. It is called phenolphthalein. Now we can move to one activity. Here we used the acid, hydrochloric acid, and base, sodium hydroxide. Okay, hydrochloric acid and base sodium hydroxide, and the indicator here we use is phenolphthalein. Okay, it is the very important indicator. It is called phenolphthalein. So we can move to the activity.
Here, let us perform an activity to know about neutralization reaction. Click each tab to know more. Take a test tube, clean it using a clean dropper. Pour 10 drops of hydrochloric acid carefully in the test tube. Now, add 2 drops of phenolphthalein indicator solution. Observe the color changes. Now, add sodium hydroxide solution drop by drop to the test tube. Shake it well after adding each drop. Observe the change in the color of the solution. Keep adding the sodium hydroxide drop by drop until the color begins to turn pink. Once again, add drop by drop of hydrochloric acid to the solution mixture until the solution in the test tube becomes colorless. In this activity, we observe that there is no change in the color of hydrochloric acid while adding phenolphthalein solution. The color of the solution in the test tube becomes pink by adding a drop of sodium hydroxide solution. The pink color of the mixture solution becomes colorless by adding a few drops of hydrochloric acid. Finally, we learned that if we add excess base, that is sodium hydroxide, to acidic solution, that is hydrochloric acid, it converts to base. Similarly, we can change base into acid. We also learned that the effect of base is nullified by an acid. When acids and bases are mixed in definite proportions, they give a neutral solution. The reaction of an acid with a base produces salt and water.
When the solution is basic, phenolphthalein gives a pink color. We already seen that when the solution is acidic, it remains colorless. When an acid solution is mixed with a basic solution, what happens? Both solutions neutralize the effect of each other. Okay, so we can say that in neutralization reaction, heat is always produced or evolved. The evolved heat raises the temperature of the reaction mixture. In neutralization reaction, a new substance is formed. This is called what? Salt. It may be acidic or basic or neutral. This salt may be acidic or basic or neutral. So we can say that neutralization reaction, the reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat. So we can write an equation or an reaction acid plus base gives, this arrow mark gives salt plus water. Here we use acid as hydrochloric acid, or we can write it HCl plus a base. Base is sodium hydroxide. Gives what? Sodium chloride. Sodium chloride is salt. The salt plus water. This is one example for neutralization reaction. Hydrochloric acid plus sodium hydroxide gives sodium chloride plus water. Okay. Now we can move to the next topic, neutralization in everyday life. Neutralization in everyday life. First one, indigestion. Hydrochloric acid in the stomach helps to digest food, but too much acid causes indigestion. To relieve indigestion, we take an antacid such as milk of magnesia, which contains magnesium hydroxide. What happened when magnesium hydroxide intake? It neutralizes the effect of excessive acid. Okay. Second one, ant bite. When an ant bites, it injects the acidic liquid, that is formic acid, into the skin. We are already learned about that. The effect of the acid can be neutralized by rubbing moist baking soda. When baking soda is rubbed, what happens? It neutralizes the effect of acid. Okay, when neutralized by rubbing moist baking soda or sodium hydrogen carbonate or calamine solution, which contains what? Zinc carbonate. This zinc carbonate is basic. Okay, so this base neutralizes the effect of acid, this formic acid. Okay, third one, soil treatment. Excessive use of fertilizers makes the soil acidic. When excessive use of fertilizers, it makes the soil acidic. Plants do not grow well when the soil is either too acidic or too basic. When the soil is too acidic, what we do? It is treated with bases like quicklime, slaked lime. Quicklime or calcium oxide and slaked lime. That is calcium hydroxide. These are bases. Okay, if the soil is basic, organic matter is added to it. This organic matter releases acids which neutralizes the basic nature of the soil. Okay, then fourth one, factory waste. The wastes of many factories contain acids. If they are allowed to flow into the water bodies, what happens? The acids will kill fish and other organisms. The factory wastes are therefore neutralized first by adding basic substances. Then it is allowed to flow into the water bodies. Okay, these are the neutralization in our everyday life. Now we can move to our last session. Okay, exercise. First one, what do you mean by neutralization reaction? Give one example. Second one, what are the natural indicators? Write the color changes of them in acidic and basic solutions. There are three indicators, natural indicators. Write the color changes. Okay, then third one is sugar solution is acidic or basic or neutral. Then why? Thank you, students.